Hello everyone again. So now we continue the lecture of polymer. So previously lecture 10, first part of polymer. So this one is the next part, okay, on polymers. So this is lecture number 11. Okay, so we already have taken a look at the various type of polymers, which is thermoplastic, thermoset, elastomer, and so on. We already seen like thermoplastic is very weak, it's soft, thermoset is very hard, and we already seen the polymerization process. So by condensation reaction, you can make into polymers, and usually condensation polymerization, the polymers are usually thermosets. Okay, because a lot of thermosets are produced by that process, whereas the addition reaction, polymerization by addition, is actually usually most of the thermoplastics are being produced by this process. So now we already know how to make polymers, what are the some types of polymers, and then now we are going to see how people make into uh, the various shape and sizes. Okay, so when people process polymers into their various shape and sizes, the polymers when they buy right from the refinery is not in the shape already. That means when I buy right, it's not ready in bottle shape. No, it is in pellet form. Okay, it's like many pellets or seeds. Okay, the plastic pellets. Okay, so it's now the company that makes into the various shape and sizes. Okay, the downstream companies that uses these pellets, plastic pellet from refinery to make it into the shape and sizes. Okay, so there's five types here. First one is called injection molding. So injection means you have to inject, right? So the injector is here, this part here. So what you do is you add the polymer pellets in, okay, and then it will go inside here, and then there's heater here, so this plastic pellet will start to melt. Okay, so as it goes along, it will start melt and melt and melt and melt, so become liquid already. So there's heater here, that's why it's melt. And then this is an injector. Don't forget this, so it will be push injected through into the mold here. Don't know whether you remember the earlier lecture. This mold will determine what shape the plastic will be. Okay, so if I want the plastic the chair, so this mold will be the cavity, the space there will be looking like a chair. So this liquid uh, plastic will occupy the space here. Okay, and then it will be cooled down, and then once cooled down already solidify right into that shape, then this mold will open and this shape of the plastic will come out, or whatever shape that you want lah. Okay, so this is called injection molding. That means the plastic is melted and injected into the cavity or the mold to form that shape. Then cool down, then you get the shape there. So this is how injection molding works. Okay, heated, forced through into a mold. Then after that, you keep it inside the mold until it solidify lah. That means cool down there, and then open the mold, and then this one there's an ejector pin to eject this solid polymer out lah. Okay, and that's it. So this is injection. That means the liquid polymer is inject into the shape that you want and solidify, and you get that shape. Next one is compression. This one is like plasticine. Okay, so it's soft one like clay. That. So what you do is this plastic, the polymer, will be placed here, and then because it's compression molding, right, it will be compressed into this shape here. Okay, so this shape will determine what shape the plastic will be lah. Okay, in this case is this shape, right? Okay, so when you compress it, it will be squeezed to occupy this shape. Okay, and then you cool it, and then it will become solidified into this shape. Then this ejector pin will push. Okay, will push this polymer out from the mold, and that's it. So this is compression. Transfer is just like a plunger, like the syringe. Okay, you press the plunger down. So this is your liquid plastic. You press it down into this mold cavity here. Okay, then this they will occupy this shape now, and then again you cool it down, and it will become this shape. Okay, and then again the ejector pin will push the solid plastic out. That's transfer. That means you transfer from here to here. Blow molding is a little bit different from the first three. Anyway, the plastic that is partially melted or melted ready, it will be drip down here. This is the yellow one. Okay, it will drip down here. And then this is your mold, left side, right side. It will close, become like that. But the plastic will still be hanging down like that. So how to make it into this shape? You pass air through, compress air to push the plastic from this one to occupy the space at the side here. So you blow, then it will expand, poof, into this shape here. And then you cool it, and then it will remain this shape when it solidify. Extrusion is similar to injection. You can see here it's the same injection and so on. The only difference is that at the end here, okay, in injection molding, right? If you remember, when I squeeze the liquid plastic, it will remain in this mold, and then you wait for it to cool down, right? Then you get the shape. Whereas for extruder, right, extrusion, this is already your mold. So if the shape is here, your plastic will be squeezed out through this cavity into this shape here. So basically, right, this type of technique is useful to make tubings and pipes, and because it's one long chain of polymer coming out, like you squeeze out toothpaste like that. You squeeze out, right? Okay, depending on the cavity, the shape here. So you squeeze out like a toothpaste come out. So it will remain in that shape. So it's very good for tubings and pipings and all this because you have one long chain of polymer. But otherwise, the principle is similar. You plastic pellet put in, melted inside here, and it will be pushed out through the die here, the mold. Okay. Okay, this one just to add, right? If you want your plastic to be colored, whatever color you want, you can add colored additives inside here, and then it will mix and it will form whatever color that you add. Okay, force through a die, which is your the shape that you want it to be, and cool down lah. So it'll be one long like noodle like that coming out here. All right. Okay, so these are some of the testing that people do on the polymers. Okay, how it behave when you heat it, density, solubility, etc., etc. This one is the most common one. Let's say I'm given a plastic. I don't know what plastic is that. So the first thing I should do is just burn it in a Bunsen burner, the flame. So different plastic will have different flame color one. If you burn it in a Bunsen burner, right, the flame will change color according to the type of plastic. So in this way, you can roughly identify first what type of plastic you have. Okay, so for example here, polyethylene, right? If you burn it, it will be blue. Polycarbonate will be orange. Nylon also blue, and so on. And then when you burn, right, sometimes there is a soot. Soot is those black smoke coming up. Some polymer have black smoke one, especially this one. PVC, yes, that is your HCl coming out as soot. Very nice smell. Okay, polyurethane also nice black smoke. Okay, the flame is here and so on. So this is what people do to initial identification of the polymers. If you do not know what it is lah, then you check for density. Okay, so you can either use a hydrometer or pygmometer. Hydrometer, I believe you should already learn this in analytical camp. Solubility, so you can. This is good way to distinguish between thermosets and thermoplastics. Okay, when you dissolve it in certain solvents, thermoset, because it's very strong, right? It usually cannot dissolve. Okay, it's insoluble in most solvents. Thermoplastic soft, easily soluble in many solvents. So this is a good way to distinguish between the strong thermoset and the weaker thermoplastics. Okay, resistant to solvent. Okay, especially those thermoplastic, right? They're not so resistant to solvent, so solubility, or they can swell. Okay, and some companies do the environmental stress. That means they expose it to the environment and see how the polymer react to it, whether it's stable or start to crack and so on. Vapor permeability. So they study how the vapor is transferred through the polymers. Okay, based on the thickness of the polymer. Weathering. Okay, exposed to the environment, so all the various weather conditions, and see how it holds up. Okay, this one also is very common. Tensile strength. So tensile strength got two types. One is stress, which is what you're feeling right now, and strain. Okay, which is probably what you're feeling to your body right now. Very strain. Okay, so stress, force applied to the unit area. Strain, how much it can deform, elongate. So basically, like, stress is how strong the plastic is. For example, thermosets, the stress will be higher. That means you need a lot of force to break the polymer. Whereas strain, right, is to see how long you can pull the polymer. So that means the best one will be elastomer lah. Rubber, right? You can elongate very long, right? You can pull it very long before it start to break. So people do this to check the tensile strength. This is an example here. So let's see the y-axis first. This is stress, right? So the stronger plastic will be higher at this level here. So your fiber very strong, rigid plastic also very strong. So it's the value of the stress is high. Whereas strain is how long it can be pulled, right? So definitely your elastomer lah, see, can pull very long. Your rigid plastic cannot pull one. Because rigid, very hard one. It won't elongate. The most break only. That's it. But you need more force to break it lah. Okay, fiber, because of the property of fiber, right? It can elongate a bit, and you need a lot of stress, a lot of energy to break the fiber. Okay, flexible plastic, obviously because it's flexible, right? It can be pulled lah. That's why the strain is long. And then you have all these others testing. This one just for your info lah. Refractive index is to tell you, because different plastic have different refractive index, how it refract the light. Acid number and saponification or sap value. This one is more to see whether the reaction is complete or not, because some monomer are acidic, so they have to check whether all the monomers are fully reacted. If it's not fully reacted, then the acid number will be high. Okay, because it's not reacted, it's acidic. Iodine value is important for the addition reaction because of the double bonds. Okay, iodine value show how much double bonds inside the polymers. So by right, if you do your reaction completely, you should not have any double bond left, because the double bond is used to join the molecules to each other. So if you have higher iodine value, means your reaction is not complete. There's still monomers that is not reacted that has double bond. Okay, so same thing for OH group. Okay, you should not have a OH group inside there, because OH group is important in the condensation reaction to form water. If you still have hydroxyl value, means it's not fully reacted. Carbonyl is C double bond O. Okay. And these are some of the equipments used: infrared, UV vis, chromatography, thin layer chromatography. Okay. I think you will learn this in your final year, I believe. TLC. Okay, let's quickly go through this one. Waste management, because it's now sustainability nowadays. So plastic waste, I think now more than 14 to 22% already of the solid waste. So obviously the best, EPA is the Environmental Protection Agency. So obviously the best is use less lah. Resource reduction. Don't use so much. If cannot, then you have to find some way to recycle your plastic. You cannot, burn it to reduce all the plastic. If really cannot, like your thermosets, right, very hard to burn. Landfilling, just cover it so that nobody can see. Yes. Okay, so but landfilling, you have to consider all this. Okay, they nowadays landfill, especially Singapore, right? Not cheap to use. You have to pay. Okay, because we have limited land here. Okay, tipping fees, landfills. Yeah, not cheap. Recycling of polymer, it depends lah. Depends on the polymer. If the polymer can easily degrade or easier to degrade, then landfill lah, because over time it will degrade. Combustible, you can actually burn it to recover back the energy that is released, or you can just recycle it lah into whatever your creativity. I think during green tech, you're expert already, right? Recover all the plastics and polymer and so on. Yes. Okay. I'm not sure whether you noticed, but actually there is each plastic container there should be a recycling code to tell you to segregate it according to the type of plastic. Okay, because the different plastic will have different treatment on how to recycle it. Okay, it's not all the same one. So that's why they have this code here so that you separate the plastic by the type. But I think nobody care like this one. Okay, but there is a recycling code to show you like this one. HDP, LDP, what type of plastic it is. All right, so that's that for this lecture. Thank you.